Hi, my name is Jonathan Magee. I'm a Senior Cortex Cloud Domain Consultant here at Palo Alto Networks. Today we're going to talk about cloud native security, and in particular we're going to look at AI-driven defense from code to cloud to SOC. The topics that we're going to cover today are why the traditional approach to cloud native security isn't working, the challenges that we have with cloud native security, reimagine CNAPP, how do you stop risks from reaching production, how do you prioritize and remediate risks from code to cloud with AI-powered cloud posture, how do you stop cloud attacks with AI-driven prevention and detection, and how you transform SOC with AI-driven security operations platforms. At the end, we'll discuss the amazing outcomes and all of the benefits of this approach. Today, I want to take you on a journey through the challenges we face in cloud security, a landscape that's rapidly evolving and increasingly complex. In modern enterprises, we're dealing with multi-cloud environments where organizations deploy a myriad of assets across diverse cloud platforms. These assets are not only numerous, but also highly dynamic. Ephemeral environments, such as containers and serverless functions, are spun up and taken down in seconds, making it increasingly challenging to maintain consistent security. Along with this complexity, we're seeing an explosion in both new capabilities and new attack vectors. As cloud platforms introduce advanced functionality, attackers are quick to exploit any gaps, and often these sophisticated threats catch traditional cloud security measures off guard. Compounding the issue is the reality is that, for example, many developers, who are architects of these cloud-native applications and services, aren't necessarily security experts. They're focused on speed and functionality, which can lead to security being a secondary consideration. This is where the concept of AI-driven defense becomes crucial. Today in the real world, artificial intelligence isn't just a buzzword. It's a necessary evolution in our approach to security. Hackers are now harnessing AI to launch rapid and sophisticated attacks. As cybersecurity professionals, we must harness AI's transformative power to fortify our defenses and protect our cloud environments. AI-driven tools can help automate threat detection, predict vulnerabilities, and respond in real time, ensuring that even the most transient environments are continuously monitored and protected. But are tools enough? Well, no. A cloud security platform is required. The platform must excel in unifying the strengths of robust application security, cloud security posture management, cloud runtime security, and if that's not enough, it needs to be fully integrated with the SOC. Along with cloud detection and response, these are crucial components that combine to form a single end-to-end cloud security platform. This is a bold step forward. This unified approach means you no longer have to juggle separate solutions that barely communicate with each other. Instead, you have a consolidated cloud security platform that covers the entire spectrum, from code to cloud, right into your security operations center. This delivers a significant reduction in complexity and a more agile and proactive security posture. With all these technologies working seamlessly together, we're well equipped to defend against modern, sophisticated threats. It's a holistic solution that today's cloud environments require in order for us to be one step ahead of potential attackers. Let's take a brief look at the history of cloud security evolution. Many years ago in, let's call it phase 1, when organizations first embarked on their cloud journeys, the focus was on cloud security posture management, or as we all love to call it, CSPM. Understanding what assets we had in the cloud and identifying associated risks was the primary function of this tool. This has evolved into, let's call it phase 2, the advent of CNAPP. And what is that? Well, CNAPP is a combination of application security, our CSPM tooling, and cloud runtime security to offer a more integrated approach. Now we are entering phase 3, integrating CNAPP with the SOC. This next step reduces non-contextual alerts, automates remediations, and significantly cuts down on the mean time to remediation, or MTTR. Historically, cloud security has been segmented into a number of distinct areas. On one side, we have our shift left capability, where we look at the application security. And as we move towards what we would call the right side, or runtime security, we see tools and solutions designed for posture management and cloud runtime security. All of these combined have led to the rise of what we now call the CNAPP, or Cloud Native Application Protection Platform. These tools operate during peacetime, where you're not under active attack, giving you ample time to identify misconfigurations, fix vulnerabilities, and align your development teams with best practices. As we move forward, the integration of CNAPP with the SOC represents a significant evolution in our defensive strategy. one that transforms how we manage and respond to threats in a unified, efficient manner. However, peacetime solutions alone don't stop an attack in progress. Once an adversary is actually attempting to breach a system, we need robust protection, an entirely different set of capabilities focused on live environments. Then there's a Security Operations Center, which requires deep code-to-cloud telemetry data in order to rapidly detect and respond to incidents. This is your wartime function, where every second matters. Because these domains, CNAP and SOC, have evolved separately, we have been left juggling multiple tools and dashboards that rarely speak the same language. It creates an enormous amount of operational overhead. Teams spend more time trying to stitch data together than actively preventing or mitigating threats. The question then becomes, how do we effectively move from simple detection to genuine prevention with each piece of the puzzle is handled by a separate system? Another factor compounding this issue is the sheer volume of alerts. The cloud security market has churned out countless tools that generate millions of findings. In fact, it is estimated that most customers using these tools will have on average 1.8 million findings. When you have that many red flags popping up, you risk alert fatigue. Critical issues get buried under a flood of less urgent warnings. Ultimately, the siloed approach and high alert noise combine to reduce security effectiveness. What we need is a more unified perspective, one that is AI driven, integrating application security, cloud security posture management, cloud runtime protection, and SOC capabilities. By reducing silos and ensuring consistent contextualized insights, security teams can focus on meaningful prevention rather than being overwhelmed by detection-only alerts. In a landscape where threats evolve quickly, this end-to-end strategy is what empowers security teams to keep pace and stay resilient in the cloud. Now that we understand the challenges, let's talk about the re-imaged CNAP, and that delivers real-time protection by unifying everything we have learned about application security, cloud security posture management, and cloud runtime protection. We're now developing and deploying security platforms focused on unified data, intelligent automation, and AI capabilities. We've seen what works in the world of cloud security, first through pioneering solutions that establish the foundations for cloud posture security, and then by extending the success into application security and runtime security. Today we are taking that hard-earned experience and re-architecting the entire code-to-cloud CNAP platform to complete the operating model for cloud security. That's a lot of words. What does that mean? It means that we're not just laying new tools on top of old ones. We're integrating every piece of data, from the application code, through every stage of the cloud operations, all the way to the Security Operations Center in one unified model. For a second, let's imagine a platform where everything you see, including the broader enterprise context, converges into a single source of truth. A unified data model is essential as it empowers security teams with complete visibility and context, enabling them to make faster, smarter decisions. By leveraging the proven foundations of data, AI and automation, this new approach transforms how we protect cloud environments, not just about detecting threats after they occur, but proactively preventing them and automating responses in real time. And key to this transformation is integration, bringing all this data and context into the SOC. When your SOC can see the cloud as seamlessly as it does the rest of the enterprise, we eliminate blind spots, we reduce alert noise, and ultimately gain the ability to respond to incidents with unprecedented speed and precision. In fact, by unifying these elements, we significantly reduce the mean time to respond, a critical metric which quite frankly is in dire need of improvement today. When you have a unified platform that feeds a SOC with comprehensive contextualized data, response times drop dramatically, and security teams can contain threats before they evolve into breaches. A reimagined CNAP is about taking all our learnings from unified data and AI to automation and integrating them into a single coherent platform that spans code to cloud to SOC. It's the only approach that empowers security teams to achieve real-time protection, ensuring that every threat is met with a swift, informed, automated response. Now that we understand the challenges and the solutions, how do we apply all of this? Well, let's start with application security. Security can't be a secondary consideration in the software development lifecycle, or SDLC. It has to be an integral part of it all, from code creation to production deployment. The goal is clear: eliminate risks as they occur and remediate issues right at the source. To achieve this, a cloud security platform must consolidate all of your application security tools into one unified risk, policy, and automation engine. The approach brings together application security use cases such as IAC, information as code misconfigurations, open source software vulnerabilities through software composition analysis, developer secrets with visibility into the entire development and DevOps engineering ecosystem, as well as including insights from third-party findings. What does that mean? It means we now have a centralized view of the application security posture, enabling us to apply context-aware security policies consistently across the software development lifecycle. Through this consolidated approach, secure application deployments aren't slowed down by cumbersome disconnected tools. Instead, they're accelerated by a prevention-first approach. Security transforms from being a barrier into an agile guardrail, empowering developers to seamlessly incorporate best practices right within their native tools. This integration ensures that code is written and pushed through pipelines, risks are identified and remediated in real time. The true power of this approach comes from unifying code, pipeline, runtime, and application context. By connecting these dots, risk can be managed not just on their presence, but by assessing the probability of exploitation and understanding the potential business impact. In other words, you can prioritize remediation efforts based on what matters most to your organization, addressing issues at their very origin before they have a chance to ripple out into production. This isn't just about reducing the number of alerts. It's about fundamentally changing how we think about security. Instead of reacting to issues once they become embedded in live environments, we're turning prevention into our first line of defense. This means fewer surprises in production, less operational overhead for security teams, and ultimately a more robust, resilient application landscape. By shifting left, you create a development environment where security is proactive rather than reactive. It's a strategy that not only minimizes risk, but empowers developers to build better, more secure software from day one, making the entire process faster, more efficient, and far more secure. This approach sets the stage for accelerated, secure deployments that keep pace with today's agile development cycles, ensuring that at every step, from code to production, is safeguarded against potential threats. Now let's dive into Cloud Security Posture Management, or CSPM. So how does AI help us improve our cloud posture? Well, it allows us to prioritize and remediate risks from code through the cloud. Modern cybersecurity platforms help us to maximize cloud security posture in the most efficient way possible. It starts with a single, streamlined onboarding workflow that builds a complete inventory of your entire cloud stack. This means you get a comprehensive view of everything, from your cloud infrastructure, your cloud native applications, your data, your AI environments, to your network configurations and identities. With all these assets cataloged, you have the critical telemetry needed to understand your environment in detail. Once you have this dataset, AI models correlate security issues and alerts to identify potential attack paths to your most critical assets while suggesting remediation steps or even applying these steps through automations for you. For example, imagine a scenario where a publicly exposed virtual machine is running a vulnerable component, say Log4j, and it also holds administrative privileges. This creates a clear pathway for a lateral movement to sensitive data stores. And this is just one among hundreds of possible attack scenarios that a unified platform can detect, ensuring that no potential breach factor is overlooked. Identifying risks is crucial, but it's only half the battle. Taking effective action against these risks is where many tools fall short. Traditional posture tools might simply generate a ticket for every single issue, resulting in hundreds or even thousands of tickets that quickly become unmanageable. Instead, let's change the approach. Let's focus on pinpointing the single underlying problem that's causing multiple risks across various cloud assets. For instance, if one misconfigured IAM role is enabling several attack paths, AI and machine learning will correlate these and recommend addressing that single issue through remediation steps. By applying or auto-remediating with one fix, we can effectively break down dozens of attack paths, streamlining the remediation process significantly. This targeted strategy not only reduces the noise and the number of remediation workflows, but also frees up security teams to focus on high-impact changes. By consolidating and prioritizing risks based on both the probability of exploitation and their potential business impact, you can ensure that the most critical vulnerabilities are addressed first. This approach provides a proactive, prevention-first strategy that stops risks before they materialize in production and empowers security teams to remediate issues at the source, delivering a comprehensive, efficient, and actionable view of your cloud security posture. It consolidates vast amounts of data into meaningful insights, automatically identifies attack paths, and offers targeted remediation actions that dramatically reduce the workload and complexity of maintaining a secure cloud environment. We've addressed application security, and we have addressed cloud security posture management. But how do we embrace cloud runtime security and stop attacks before they become full-blown breaches? In today's dynamic cloud environments, your workloads, ranging from hosts and containers to Kubernetes clusters, serverless functions, web apps, and APIs, are all under constant threat. Attackers exploit vulnerabilities using zero-day exploits, malware, malicious behavior like unauthorized crypto mining, or even by taking advantage of known vulnerability exploits. Let's imagine having a unified cloud security platform that continuously monitors these diverse components in real time. By harnessing advanced machine learning techniques, we can detect subtle anomalies and behavioral deviations that might indicate an emerging threat. It's not just about reacting once an attack is underway, it's about preventing it altogether. AI-driven methods like anomaly detection, malware analysis, and behavior modeling work together to scrutinize every layer of your cloud environment. For example, if a zero-day exploit is targeting one of your workloads, AI algorithms can analyze unusual traffic patterns or unexpected system behaviors and flag these deviations immediately. Similarly, if malware attempts to infiltrate a container, or if there's an unusual spike in resource usage, suggesting crypto mining or a coordinated vulnerability exploit, the platform can automatically trigger containment and remediation processes. This proactive stance ensures potential threats are neutralized before they have a chance to breach your defenses. What makes this approach powerful is its ability to adapt and learn over time. With continuous feedback from real-world incidents and vast amounts of telemetry data, the AI models improve their accuracy, reducing false positives and focusing the team's attention on genuine risks. This means fewer unnecessary alerts and more precise interventions, which is critical in the high-stakes environment where every second counts. By integrating these AI-driven preventions and detection mechanisms, organizations can move beyond traditional reactive security measures. Instead of waiting for an incident to unfold, you now have a robust system that actively prevents threats from escalating into breaches. It's about creating an environment where security is baked into runtime, offering a seamless shield that evolves alongside the threat landscape. An AI-driven cloud runtime security platform provides comprehensive protection for your entire cloud stack, leveraging machine learning to detect and mitigate zero-day exploits, malware, and anomalous behaviors, ensuring that defenses remain agile and effective. The approach not only safeguards assets, but also empowers security teams to focus on strategic, high-impact initiatives whilst keeping the cloud environment secure and resilient in the face of ever-evolving threats. The final stage in adopting this innovative approach to cloud security is through the SOC, delivering an AI-driven security operations platform. In today's security landscape, data is our most powerful asset. When we're preventing attacks in real time, every piece of information matters. Our approach begins by capturing data not only from runtime agents monitoring your workloads, but also from raw cloud sources. For instance, audit logs, DNS queries, flow logs, and other relevant data from various enterprise tools. By bringing all of this information together, you form a holistic view of the environment that spans across the cloud. This isn't just about collecting data. It's about turning raw information into actionable insights, using advanced AI and automation, enabling the platform to stitch together disparate detection data and transform a flood of alerts into prioritized incidents. This means that instead of security teams being overwhelmed by noise, they receive clear, context-rich alerts that are ranked by their potential impact. Automated remediation steps can then be applied to tackle as many issues as possible, streamlining the entire process and ensuring that only the most critical issues reach human analysts. What makes this approach truly transformative is its seamless integration with the SOC. Rather than maintaining a separate shadow cloud SOC function that operates in isolation, the strategy extends the native capabilities of the enterprise SOC into the cloud. This integrated model leverages the power of AI across both cloud and traditional data sources, ensuring that your entire security ecosystem works in harmony. The result is a unified security operations center that quickly correlates data, detects anomalies, and responds to threats regardless of where they originate. By natively extending advanced SOC capabilities to the cloud, you not only gain a centralized view of your security posture, but also eliminate the gaps and silos that often leave organizations exposed. This holistic view enables faster decision making, reduced response times, a more proactive approach to security. The benefits are clear: fewer false positives, more efficient incident management, and a dramatically enhanced ability to protect critical assets across your entire enterprise. Transforming the SOC with a complete AI-driven security operations platform means harnessing all of the available data, from runtime agents to raw cloud logs, and turning that into prioritized, actionable intelligence. This approach ensures that security operations are not only more efficient, but also deeply integrated, eliminating the disconnect between your cloud and enterprise security functions. Ultimately, it empowers teams to detect, prioritize, remediate threats more effectively, ensuring a robust defense against modern dynamic cyber threats. Now, as we wrap up the discussion and bring all of the benefits together, let's look at the outcomes we can achieve with a code to cloud to SOC platform approach. This isn't about integrating disparate tools. It's about transforming the entire cloud security workflow from the ground up and realizing significant measurable benefits. Imagine a scenario where you're reducing your risk by as much as 90% by shifting security left. By embedding security in your development processes and catching vulnerabilities early, you're ensuring that the vast majority of issues never make it to runtime. This proactive approach not only minimizes your exposure, but allows developers to focus on building innovative solutions without the constant worry of latent security risks. But the benefits don't stop there. When you consolidate your security tools into a single platform, you also achieve a dramatic reduction in noise and workload. With intelligent grouping and prioritization, you can see up to 25 times fewer posture alerts. Instead of being inundated with countless notifications and remediation tickets, your team receives targeted, actionable alerts. This means that every posture case is not just a ticket. It's a meaningful step towards preventing attacks in real time. This means that every posture case is not just a ticket. It's a meaningful step towards preventing attacks in real time. It translates into less manual effort, fewer distractions, and more manageable security operations. And for your security operations center, the payoff is even more significant. By reducing the number of issues and streamlining the alerting process, you enable your SOC to operate more efficiently. In fact, the unified approach can lead to a 96% reduction in the mean time to remediation, or MTTR. When your SOC can address incidents in minutes rather than hours, it means that the window of opportunity for attackers is dramatically narrowed. Fast remediation not only minimizes potential damage, but also reinforces a culture of proactive defense across the organization. What does all of this mean in practical terms? It means that organizations can achieve a level of security where the development teams, operations teams, and SOC teams are all working in harmony. Risks are identified and neutralized early. Posture alerts are intelligently prioritized, and incidents are remediated with unprecedented speed. The result is a robust, agile security posture that keeps pace with modern cloud environments, all the while reducing the operational overhead and stress in your teams. These outcomes aren't just statistics, they represent the fundamental shift in how security is managed. By aligning development, runtime security, and SOC capabilities in one seamless ecosystem, you not only protect your assets more effectively, but you also empower your teams to innovate without being weighed down by excessive security burdens. Thank you for joining me in this journey through the code to cloud to SOC platformization approach with Cortex Cloud at Palo Alto Networks. Thank you.